founded Symantec in the early days as you were just getting started. Thinking back, can you describe for me what the funding meant to the company as you were just getting started?
Well, it meant the difference between starting and not starting. It meant everything in those early days. In 1978, there was a group of scientists at Stanford Research Institute and at Stanford University that came together and started a little company called Machine Intelligence Corporation. And it didn't have very much money. Although we did pool our resources, we could really only sponsor one project, and that was in the area of machine vision, sort of eyes for robots. But we had a lot of other talent in the group, and the area of artificial intelligence, in which all of us were experts, seemed to be ripe for bringing to market many new ideas. And fortunately, the National Science Foundation came along at just the right time and offered a grant for small business. So we applied and we received it, a whopping $25,000 grant. And with that grant and with a follow-on, we were able to develop a technology called semantic grammars, and that's the semantic from which the word Symantec eventually came. So with the follow-on grant, we were able to spin Symantec out as a separate company, and with the prestige and with the confidence that comes from having a National Science Foundation grant, and along with the research results that had come from doing the work under the grant, we were able to obtain venture capital. And the venture capital was a huge multiplier because it came in well over an order of magnitude more than what the government had invested in Symantec. And with that money, we were able to hire more people. We were able to turn the research into an actual product. And then that product became hugely successful. That product was called Q&A. It sold thousands of copies. And the revenues from that were then plowed right back into the business. We created more products. We were able to acquire a number of other startup companies who were undercapitalized or just didn't have the infrastructure to bring their products to market, even though they had good products. And it was just like a snowball rolling downhill. And it just got bigger and bigger and bigger and gained momentum. And it all started with that little $25,000 grant. And now today, Symantec has revenues of well over $6 billion a year. It employs over 18,000 people. That's a lot of jobs from a $25,000 grant. And it's number 353 on the Fortune 500 list.
Wow. That's amazing. It was so the very first grant you got, the very first business grant you got was from NSF was $25,000?
That's exactly right.
Wow, that's amazing. So obviously the direction of the company's changed over the years, but as you said, it has become huge. You've already somewhat answered this, but what kind of connection do you see between the type of public funding that helped get that company off the ground, your company, years and years ago, and research, innovation, linking that to economic security and jobs?
Well, the research that got Symantec going is just part of a huge, huge story about science and technology through the ages. If you think about it, what really creates wealth in a society, what really causes economic growth is it's always innovation. That's the thing that drives it, because innovation drives productivity, and productivity is the basis for economic growth. Now, if you're in an emerging nation, you can take innovation from a first world company and apply it to your society and get great benefits. That's what's going on in China and India right now. But if you're a first world country, you've got to innovate yourself. Now, innovation comes in many forms. It's not all science. For example, the invention of money was a wonderful innovation. It wasn't exactly a scientific breakthrough to think of money, but it really helped. But through the ages, the really big multipliers have been technological in nature. Think about the internet. Think about the PC. Think about the internal combustion engine, or going back to the granddaddy of them all, the Industrial Revolution. These were the results of science and technology. And that's where all today's modern prosperity comes from, was from those scientific innovations. So if we think about that going forward, the countries that are going to have economic stability are the ones that are going to have economic growth. Those have to be the ones that have increasing productivity. That productivity has to come from innovation, and most of that innovation traditionally has come from science. So how do we get more of it? We invest in basic research. That's as simple as that.
So it's a good investment for the public, for tax dollars through, agencies such as NSF passing through to young, innovative companies.
Well, that's exactly right. The nature of scientific research is that it is a very, very high risk. And this means that many of the efforts will fail. If you put all the responsibility and burden of that potential for failure on the backs of entrepreneurs, they're going to be unlikely to give it a try, simply because it's too much risk. There may be great reward, but since the failure rate is very high, most people would be afraid to play the game. But government with deep pockets and broad perspective has the wherewithal to assume that risk, because if you play in sufficient numbers, if you play the game enough time in sufficient numbers and you know that the odds ultimately are stacked in your favor, then as a society this makes a great deal of sense, whereas it may not make a whole lot of sense to one individual to take on that risk.
Okay, thanks, Gary. I just have one more question, just to follow up when you're talking about risk, and you raised a really good point. When you're investing in science and innovation, you don't always know, sometimes you're going to end up answering questions you didn't even know you were going to ask. And it is a risk, and you may not end up where you thought you were going to end up. There's going to be failures as well as success. That is the nature of the beast, though, right?
Well, that's exactly right. You don't know what's going to happen. You don't know when the payoff is going to be. We've seen many examples in history of a scientific breakthrough that's economic potential wasn't recognized for many, many years after the inventor had died. So you don't necessarily have the immediate payback. And of course, someone who is risking their own capital is always thinking about how they're going to get an immediate payback. So thinking of all this in terms of it being somewhat like going to Las Vegas. A particular person going is probably going to lose their money. But if you're the house and things are stacked in your favor and you can play the game over and over and over again, then you're going to be a big winner like the casinos are. But you can be an even bigger winner with science, because in the casinos it's a zero-sum game. For every winner there has to be a loser. In science, although you often lose, when you win, you win in a big, big way, and you pay for everything that's lost, and then you gain ever so much more for the people who actually did it and for society as a whole. So things are really stacked in your favor when you do that.
That's an excellent answer. I personally think of it as exploration. You don't discover unless you explore.
Well, that's right. When you're doing something as an enterprise, you really need to be able to find something quickly. Otherwise, you run out of money. So there's a difference between research that would be done by, say, the Small Business Administration, where you're trying to fund an enterprise, you're trying to do something that's fairly short term, and you're hoping that it will be productized very, very quickly in order for that firm to have the wherewithal to keep going, as opposed to research that's done in universities. In the universities, you don't need to have that immediate payback, and therefore the science that's done in universities can be much, much higher risk, and ultimately it can have, because of the nature of it being higher risk, it can have much greater impact. So the National Science Foundation has a role to play. both in funding small startup companies where you hope to have an immediate return, and in funding much more fundamental research on a grander scale at universities and research institutions.